So for number 6 here, the cancellations only occur when you're multiplying. You have to be multiplying, not adding or subtracting. So if this were a multiplication in the middle, yeah, these would cancel. But since it's not, you can't cancel those. So this one is actually also a no. So let me actually back up here. I think we should probably go through a couple of these other ones that I see here. Boy, this is really written really oddly, but that's okay. Let's go to number 2. So number 2, your answer is correct, but I want to just make sure it's you understand why the reason is correct here. If in the bottom everything's okay because it's parentheses x plus 3 and parentheses x. In the numerator, you really got these extra parentheses on the outside. So that's 2x plus 3 over x plus 3 x. And this is what you're looking at. That's what you're trying to decide. Is it exactly the same?
No, it's not.
And that's not. That's what I said. Your answer is correct, but not. We gotta be careful that we do it for the right reason. Here. So let's look at 3. 3 is kind of interesting. Actually, a real good problem here. I might use this myself at some point. So you said no here. We're going to just cross that out for a moment. And because it kind of looks like it's no, but you can actually factor out in the numerator, factor out an x plus 3 from both. Okay, so like there's really a 1 in front of the x plus 3 on the left. So it becomes in the numerator x plus 3 times 1 plus x over x plus 3 times x. And this is your reason. Like these cancel now, and this is your reason. This is a yes.
Okay.
So let's just keep going down in order here. We talked about 7. 7 is good. 8 is good. All right. We have 9. 9's got a little thing to talk about. All right. So with number 9, again, you want to factor wherever possible. All right, so in the numerator, do you see that there's an x in both terms?
I do.
And that factors out. So you get x times x plus 2 over x squared. And do you see now that at least one x cancels because you got 1 in the top and 2 on the bottom?
Yeah.
And that's your reasoning. That's your justification for that. You don't really need words. You just need to show some work here. All right, so any questions on that before we move on?
No.
Okay, so 10 looks good. 11, your answer is correct on 11, but I want to ask you, what does it reduce to when they cancel?
1.
Yeah, it becomes 1 over 1. Good. All right, let's look at so 12. 12, we're going to factor the denominator. Okay, so before we go with no, can anything factor in the denominator? Greatest common factor. Remember, it can be a number, can be a variable, or it can be both.
Yeah.
What goes into both 12 and 16? What's
4.
the biggest? 4. So you got 4x squared over 4 times 3 plus 4x squared. Now what's interesting is it says, can we cancel anything? So that's why this works, or that's why this answer is now yes, because the 4's cancel. But usually they're looking for factors of X exclusively. So you might want to maybe clarify that with your instructor. 13 is good, 14 is good, 15 is good. 16 is, just take another look at 16. Maybe you can see it now, what cancels, now that we've done a couple of these. Do you see anything that cancels now?
One of the X's.
Nope, it's got to be in parentheses. It's got to be entirely in parentheses.
The 3.
3 plus 2x. So that's why I've been putting parentheses around everything, because it really helps to identify what can and cannot cancel, but because they have to be in parentheses. Who masked? Who did the smiley face?
Oh, I have no idea.
Okay, all right, just a random emoji. Okay, let's go look at 18 now. 18, you want to factor the numerator and denominator if you can. Okay, so you're trying to find two numbers that multiply to 3 but add up to 2.
Mm-hmm.
So like 1 and 3, do those add up to 2?
Yeah.
They do.
Oh well. Oh my gosh. Give me a second.
That's the risk with 8 o'clock. You gotta decide if you're still in math mode or not. So the top does not factor because there's no numbers that multiply to 3 but add up to 2. Positive 3. Even if you're like, hey, what about -1 and -3? Well, that's -4. No good.
Yeah.
Okay, on the bottom, you want to find two numbers that multiply to 2 but add up to 2. So does 1 plus 2 add up to 2?
No.
No, a -1 and -2, which don't even make sense because it's good that, but we'll just throw it out there. No, it doesn't work. So you're just looking at these. They have to be exactly the same. Are they exactly the same?
Yeah. No.
They have to be exactly the same. Like everything has to be the same.
No.
It's actually very rare in nature to actually have two things be exactly the same. But in math textbooks, it's a little bit easier to figure that out. Do you have any twins in your school?
I do.
And are they exactly the same?
Yes.
What? No. Biology, right? They're different DNA. There's always like a little bit, tiny little bit of difference between them.
I mean, they look exactly the same. So,
Okay. All right, we're gonna move on from that. All right, so let me give you another example here. So this is really what I think your instructor was trying to achieve when they gave you this problem. Okay. And let's do it we'll do Swiss numbers here. So we got 4x squared. Okay. So you're supposed to identify things that are the same on the top and the bottom. Can you identify anything that's the same on the top and the bottom here?
x plus 2.
Anything else?
X minus 3.
Yes. Okay. Now, they don't have to be exactly the same. They just have to be able to cancel out. So do you see how an x with an x squared could cancel out?
Yeah.
One of the x's in the top cancels with one of the bottom. How about the 8 and the 4?
I mean, you could reduce it to 1 and 2.
Right. So 4 goes into both. And there's your cancellations. Okay. Now, the difference between this problem and the ones that you were seeing is that this is like fully factored. Okay. So what I mean by that is, let me give you another problem here. Let's say I give you something that's like x squared plus x over x cubed plus x squared. Okay. Now I want you to tell me, are they exactly the same on the top and the bottom? Are
No.
these? No, they're not the same. They're a little bit different, but you can factor them What can you factor out of the top?
You can factor out. You can factor out 1x
Yes.
for x squared. Yeah.
Okay, now what goes in the parentheses?
X plus 1.
X plus 1. Now in the denominator, what can you factor out of both?
X squared.
X squared. What goes in parentheses?
X plus 1.
Okay, now do you see any cancellations?
Yeah.
What are your cancellations?
X plus 1.
Okay.
And you can cancel out one of the x. With the
Yeah,
other one.
exactly. So I think where you were running into problems is this kind of the obscure nature of this assignment, where it would be like x plus 2 over 2x plus 2. Okay, and you really have to treat this like, okay, that's x plus 2 in parentheses, but on the bottom I could factor a 2 out, x plus 1 in parentheses, and you put everything in parentheses, and the only things that can cancel are what are in parentheses. So does anything cancel here?
No.
No. Okay, now your instructor put up a problem on the board here. This is where you're moving in the course, which is how to add and subtract these fractional expressions. Should we work on some of those now?
Yeah.
Okay. So let's do this. It's like 1/3 plus 1 over x. We kind of started this last weekend. We need to make a common denominator. What is the common denominator between 3 and x?
3x.
3x, perfect. So you can write it over 3x over 3x, and you got to figure out what's missing here. So it's like x and x is missing, 3 and 3 is missing. So it becomes on the top, becomes x plus 3. Do you see that?
Yeah.
Okay, so you can rewrite it as x plus 3 over 3x, something like that. Now where it gets more difficult, okay, is when they're not just single expressions. Like this is what you're going to see on a quiz or something, test or quiz coming up. It'll be like 1 over x plus 1 minus 2 over x minus 1. What is the common denominator in this case?
It could go either way because you could multiply it by, well, negative because that's easier.
Well, so whenever you got a product here, this becomes a product. It becomes the common denominator is x plus 1, x minus 1. So you take if you're not sure, you just take the one that's missing and multiply it on the other side.
Okay.
Do you remember that, seeing that in class?
Yeah.
Okay. Now in the numerator, it's 1 times x minus 1, sorry, x minus 1, minus 2 times x plus 1. So do you remember what to do from here? How do we simplify this?
You cancel out x plus 1.
No, if you cancel out, you're going backwards. It's like making 4 right turns. You just get back where you started. You want to distribute this on the top. Like you want to distribute this as -2 into both of these. So it becomes on the top x minus 1 plus -2x minus 2. Do you see how I got that? How you distribute the -2 to both terms?
Yeah.
Okay, now if you get that, we can now combine terms in the top, like x goes with minus 2x is minus x, minus 1 goes with minus 2, minus 3. And this is in parentheses, x plus 1, x minus 1. So what about this did you not understand? What was unclear about this? All right, so you find the common denominator.
Yeah.
And then you've got to make it common, so you multiply the other one by what is missing, and then you distribute, combine like terms. So yeah, it's a lot of work, but it's not impossible here. Now let's try another one here. Let's say it's 2 over x plus 2 plus 3 over x minus 3. So what your immediate focus should be on, okay, my common denominator is the product of these. So what do you multiply each of these fractions by? And it's always the other one. It's like, all right, I've got an x plus 2 already. See, I've got an x plus 2. I'm missing an x minus 3. So since you're missing it, you multiply the top and bottom by x minus 3. So we already have the bottom. Do you see how the bottom's is just rewritten in a different order?
Yeah.
In top, you write 2 times x minus 3 plus. Now over here, it's like, what am I missing on the right here? 3 over x minus 3. Well, I'm missing the x plus 2. Don't have it. So 3 times x plus 2. It's kind of like cross multiplying. It's like, all right, x minus 3 up there with the 2, x plus 2 over there with the 3. Okay. And then this time you have to distribute in on both. So it becomes 2x minus 6 plus 3x plus 6. And when the denominators are the same, you just keep it. X plus 2, x minus 3. Can you tell me what the numerator reduces to? Combining like terms?
It'd be negative x.
2x is positive, then 3x is positive.
But there's the, oh, never mind. I was looking at the minus in front of the 6. So it'd be 5x.
Yes, 5x. 5x over x plus 2, x minus 3. You ready to try one on your own here?
Sure.
Okay. We won't make it too bad. Let's go with 2 over x minus 4 plus 3 over x plus 1. Go ahead and reduce that for me, please. I'll check back with you in a minute or two.
I got 2x plus 2 over x plus 1 and x minus 4.
Like this?
Yeah.
Okay, so let's take a look here. It is 2 times x plus 1 plus 3 times x minus 4 over x minus 4, x plus 1. So the order does not matter in the bottom. Totally doesn't matter here. Now, one of the things I do, and this will save you a little bit of writing, is I like to actually rewrite it above it. So like 2x plus 2 plus 3x minus 12. Okay. So no, and then I just cross this out or squiggle it out. So I've got a different numerator. Where do you think you went different than me? Paige, where are you different than me on this?
Um, oh, I didn't distribute. I just added them all
Okay.
together.
Yeah, that'll do it. So yeah, the numerator becomes 5x minus 10 over x minus 4 over x plus 1. Now, occasionally you can actually factor the numerator after you're done with this. Okay, but nothing cancels. But occasionally it does work out. All right, let's have you try another one here. I'll make this one slightly more difficult now that you've got one under your belt here. Let's go -2 over x minus 3 plus -4 over x minus 1. Give this a try, please.
I got -6x plus 13
Over.
over x minus 1, x minus 3.
Okay, very good. All right, let me take a look here. So it becomes -2x plus 2 minus 4x plus 12. So it's just a slightly different here. 2 plus 12 is 14. But yeah, looks good otherwise. Okay, now let's do another one here. We'll just kind of increase the difficulty here a little bit. So you're gonna see some problems like this, like 1 over x plus 1 over 3x plus 1 over x plus 1, something like this. Okay, now you've got 3 things, and the mistake is to just multiply them all together. Like it's not x times 3x times x plus 1. That is a common denominator. It's not the least common denominator. Okay, so like, do you see how x and 3x are really like a multiple of each other?
Yeah.
So you really want to take that into consideration. Like it's Yeah, it's x, but there's a 3x. That's the kind of the increase in the common denominator times x plus 1. So this is your least common denominator here. And we'll do a few more examples, so maybe it'll become clearer. Now, what you do is next is you look at each of the ones that we've got above here, and you're like, what are they missing? Like, what is the 1 over x missing? Like, what does it not have for this common denominator down here?
What
Do you
is
see
the
it?
1 over x not have?
Do you see how it's missing a 3 and an x plus 1?
Yeah.
So you have to multiply top and bottom by a 3 and an x plus 1.
Okay.
Now on the bottom, there's nothing to do. You're just figuring out, but the top is what you care about. The top is, okay, it's 3 times x plus 1. Now in this middle one, what are they missing?
They're missing the x plus 1.
Yeah, so you do that to the top and the bottom. So it becomes x plus 1 up top. What is the last one missing here? What is the x plus 1 on the bottom missing?
3.
3x. It's got to be exactly the same. So 3x in the top and bottom becomes 3x. Yeah, these are a lot of writing, definitely a lot of writing on this. So keep that in mind here. All right, so when the denominators are all the same, you just write it one time. You don't have to keep writing them out. In the top, though, you've got to distribute and combine like terms. So 3 times x plus 1 is 3x plus 3 plus x plus 1 plus 3x. And you just have to combine whatever is the same in the top. So how many x's do you have?
On the top?
Yeah, in the top. Got 3x plus 3 plus x plus 1 plus 3x. How many do you have?
7x.
7x, you got it. And then 3 and 1 make 4. So this is your final answer. Now this is now going back to kind of the beginning. Is there anything that cancels in the top and the bottom? And to answer that, you should really write everything in parentheses.
No, there's not.
Yeah, so we're done here on this question. Okay, let's look at another one here. Let me make it a little bit easier and have you try it on your own here. So let's say it's like 1/2 plus 1 over 2 times x minus 3. Can you tell me what the common denominator would be?
It would be 2 parentheses x minus 3.
2 parentheses x minus 3. I agree. Now this is the case, okay, where, well, we'll get to that. Now on the left here, what is the left missing? What is the 2 missing on the bottom?
X minus 3.
X minus 3, x minus 3. So on the top, we put x minus 3. Now over here on the right, what is the bottom missing?
Nothing.
Nothing. Yeah, so if it's not missing, it's effectively like multiplying by 1 and 1. So you put a 1 up there, which is what was already there. But like if it was, let's say it was like 7 up top, like that, then it would be 7 times 1 down there, bottom.
Okay.
So you combine the numerators. You've got x minus 3 plus 7 over 2 times x minus 3. Are there any like terms that I'm sorry, in the top, anything you can combine in the top?
The -3 and 7.
Yes, this becomes x plus 4 over 2 times x minus 3. Now, does anything cancel?
No.
No. All right, let's try another problem here. Let's say it's 1/4 minus, I'm going to throw a minus in it. Actually, I'll put it in the top. Plus -2 over 2 times x plus 3. What is the least common denominator here that you see? Give it a try here. Tell me what you think it is. So how do you go from a 2 to a 4?
You multiply by 2.
Right. And so that like the 2 and the 4 are kind of related. So you use the 4, and then there's an x plus 3 that comes with both. So then you've got another one over 4 times x plus 3. So once you figure that out, you can then figure out what goes on the top. All right, so can you try working out this problem from here? And if you're not sure, I guess I got to answer some questions here. What is you got to figure out what the left side is missing and what the right's missing.
So it'd be x minus plus 3. And -4. Yeah, -4 on top, and then 4.
Yeah,
X.
yes. Okay, good. All right. So this becomes x plus 3 minus 4 on top, or x minus 1 over 4 times x plus 3. All right, let's try another example here. Just trying to show you all the ones you might see. Let's go -2 over x plus 3 over x squared minus 5. So we have not encountered a problem like this before, but 5 does have a denominator. What would that be?
1.
1. So I should have done this from the beginning, but we're looking at the common denominator between x squared, and 1. So maybe it's clear between the x and the x squared, it would be x squared. What about this 1 though? Where does it come into play?
It doesn't. It just
It doesn't.
comes in.
Yeah, exactly. Yeah. So your common denominator is x squared, and x squared. All right. So I want you to continue working this out from here. I'll help. I'll put what it's missing. But I want you to give me the final answer here, please.
So it would be -2x, 3, and 5x squared.
What about this right here? Right here.
Oh, minus 5x squared.
Yeah. Good. So if you were to write this out, you could write it as like minus 5x squared minus 2x plus 3 all over x squared. Now, does anything cancel?
Mm. I don't think so.
It has to be exactly the same in the top and the bottom, in parentheses, exactly the same.
Okay.
Like the twins you see at school, they're exactly the same. All right. You said you wanted to cut off a little early tonight. Is it okay if we stop here?
Yeah.
All right. Well, thank you so much for scheduling. Hope you got some value out of this tonight. If you have some time, definitely take a look, but I'll see you next time. Hope you have a great rest of your week.
All right, you too.
Okay, bye now.
Bye.